Welcome to Try, Accept, and Finally lecture. So Python will output different types of error notifications. These include type error, name error, attribute error, indentation error, and syntax error, as well as many others that I'm sure you've come across during your time learning Python. And Python allows us to manage the output error instead of relying on the default output of Python. This is where the try, accept, and finally clauses come in. These clauses can prevent errors from being fatal to your code. So if we just try a very common example here of, say, an integer plus a string, and say we have a string of a number, 90, instead of getting 100 as the output, we're going to get what's called a type error, where we can't add an integer with a string, of course. Let's say we also have a for loop, so for I in range 3 colon print I, and if we run this, we're still going to have the error. So let's say we want to have the output of the for loop, but we still want it within the same cell in spite of this incorrect code here on line 1. Well, what we can do is put the try clause here for colon, and likewise we're going to do accept clause for colon, and then just put the print in the correct indentation. And then we run this. As you can see, we have the output of 0, 1, and 2 for the accept clause. Great. Let's say we also put in the finally clause. We'll do print end code. We'll also put a print around the 10 plus the string of 90, and now you have the output of the end code. So what's happening is that even though the try code is invalid, the accept code or accept clause will have its code outputs, and the finally will always run regardless of whether the try or the accept is valid code. So even if both of them are invalid, the finally will always output code. So let's say, for instance, we make an error here as well with the accepts. We're going to get a type error, and there we go, a type error, but as you can see, the output of the print statement for the finally clause end code will always run regardless of whether or not either one or both of them are true. So let's say we make this true. So even though the accept is not valid code, it's still ignored because the try clause is valid code. And if we were to put this as free, it's still the try clause. So think of it this way. The try, accept, and finally are somewhat equivalent to control flow of if, elif, and else. So the try you can think of as if, the accept you can think of as elif, and the finally you can think of as else. Now, the exception, of course, is that finally will always run regardless. It's not a default argument where the others have to be false. And the accept, you can actually have multiple exceptions in between both the finally and the try clauses, similar to the elif with the control flow. So moving on from that, let's say, for instance, we do a function, we'll call it error, we'll do var as the parameter, and then we'll do a try clause, and let's say we do return 10 plus var, and we'll do accept. We'll do two prints within the accept clause, type error found, and then print string in caps plus, we'll do string 10 plus var, actually we'll do that, so string here, plus var, yeah, that's correct in the parentheses, and then we'll do finally as the just end code clause, and then we'll run our function. Let's say we put in 20, and we'll get end code 30. So we have the try clause and the finally clause running, and the accept is ignored. However, if we were to put in, let's say we put in hello instead, well, we get the accept clause and the finally clause running instead. So what's happening is that if we were to get rid of this string here, this str, which converts the integer into a string, then the except won't work either. As you can see here, type error found, encode, but we still have an error, type error for the code here. Okay, so moving on from that, let's put this back as a string. And what we can also do is another function, we'll call it divide. Def divide, and we'll have x and y as the two parameters. And then we'll do our first clause, try as always, res equals x divided by y. And actually we'll keep that just below it. Return res. And then we'll do multiple exceptions, so except zero division error. And this is one of the names of the errors. So remember we had type error, name error, syntax error, and so on. So we can actually give the name of the error, and Python will pick it out. So say for instance we do print division by 0 is forbidden. We'll keep that, yeah. And then we'll do one more. Let's say type error, which we've seen before, of course. Print divide by a, let's say, can't be divided or divide by a string. And then we'll do finally print executing finally clause. And then we'll have the function run. So we have 10 divided by 2, and we get, of course, 5.0, executing finally clause. So the try and the finally are valid. If we were to do 0, well, we're not going to get the type error, we're going to get the 0 division error. So as you can see here, division by 0 is forbidden. So that's what's happening when you put the name here. It catches the exact error that you're actually getting. And if we were to do, let's say hello, run this, now you have the type error, can't be divided or divided by a string. And we can actually do the same here as well. We still have the type error. Okay. And that concludes the two functions. So we move on from that. We can also do a while loop with the different clauses. So we have the clauses within a while loop, and we'll do x equals int input, enter a valid integer, break, then we'll do except print invalid inputs. Okay, so if I were to put in something random like that, then the while loop still continues with the inputs. So it's asking for a valid input. In this case, we're going to have to put in, let's say, an integer 9, and it stops. So because it's valid, this code then breaks. And if we were to run this again, let's say we put in a float, it's not valid because we need to put in an integer because there's an int here. So we put in, say, 12, it stops. If I were to remove the ints, now I can actually put in a float. Whoops. There you go, and it stops. Okay, so moving on from that, what we're going to do is something a little bit more ambitious. So if we create numbers in a tuple, so we'll do 10, 20, 30, 40 numbers. Okay, and then if we do while true, colon, try, colon, num equals input, enter an integer, so similar to what we had just a moment before. And then we'll do actually some control flow within the try clause. So eval num in numbers. So remember, when we put an input, it's actually going to be a string. So we have to convert the string into a number. So in this case, it's going to be an integer. And we're going to try and find if we have the inputs be 10, 20, 30, or 40. And if it's in there, we'll print num is in numbers. Break. So this will break the code and the while loop will end. However, if that doesn't work, then we do num equal quit. So we can actually break out of it as well. So put colon there, break. Make a space here too. I'm just going to scroll down a little bit. And then we'll do else. Print not in numbers list. And so because it's not a numbers list, it will ask you to continue putting in a valid number until you actually get a valid number that's within this tuple, or if you put quit. And then we'll do an except, so in case we put an invalid input, so print try again please, continue. So this will continue the while loop, and then of course we do a finally clause, print end code, and this will always run. Okay, so let's run this. Let's say put in 11, not in numbers list. Let's say put in something invalid, some gibberish here. Try again please, so that's referring to the except clause. And then say I put in 20, which is in the tuples number, and then you have the end of the code. Okay, great. So just to reiterate, you can put a try, except, and finally clause within a while loop, and you have the input here, and you have to of course convert the inputs, which is going to be a string that we've assigned to the variable num. You're going to have to convert that into a number, which can be either a integer or a float, and it's checking whether or not that number that we put in is within the numbers tuple, and then we print it out if it's true. If not, then we can have the else, or we can also do quit. So let's do quit as well. So let's say I put in something invalid like 11, and then I do quit, and then you have end code. Okay, so let's take this a little bit to a bit more interesting level. Let's just delete this here. We'll do chance equals 0, and we'll get rid of the try, or rather the true, sorry, and we'll do chance less than 3. So we're going to run this a maximum of 3 times, so we have 3 chances of getting the correct value that's within this numbers tuple. And what we can do is, it's very little change to the code actually. We don't really need the finally, so I'm actually going to comment that out, because it's rather annoying having the end code. It doesn't really make much sense because it keeps saying end code all the time. And then we're going to put in chance equals chance plus 1. And also for the else, we have chance equals chance plus 1. And that should be all of it, really. That should be it. Okay. So we should hopefully have the running of this code where it's going to run a maximum of 3 times. So we have 3 chances to get the correct answer. So let's say we put in 3 incorrect answers. Say 8, 3, and 6, and there you go. So it stops after the third attempts, and all of our attempts have been wrong, of course. So we try again. Let's say we put in 8, 2, but this time we put in the correct one, like say 30. 30 is in numbers. Okay. And we can also try 3, and then we'll do, let's say, quit. There you go. And we could also do incorrect, and then incorrect again, and then one more time, and there you go. So in both cases, with the except clause and also with the else, we have 3 chances of being able to put in the correct number that's going to be found within the tuples. Alright, and then we'll just do one more. This time we're going to do a function again, and we're going to call this friends. No parameter. We'll have animals equals, we don't need to put that around in parentheses, it's going to automatically be a tuple. So bird, cat, dog, cow, lamb, and say pig. And then we'll do a try clause, num equals int eval. So I'm going to have an integer, and it's going to be for an input. That should be either input, and we'll just say please select a friend. Great. Okay, so what's happening here with this input, as you can probably imagine now, is that we have the input, it's going to be a string. We need to convert the string into a number, and that number has to only be an integer because we're going to be indexing this tuples of animals. And then we do within the try clause, we're going to have another try clause. So nested try clause, and then we're going to have some control flow. If animals num in animals, print animals num. And then we do except print, you did not choose a friend. And then lastly, finally, we'll just do some sort of minor decoration here. It's purely aesthetic here. It's not really necessary. For pets in animals, print pets, print end loop. And then of course we'll do an except. I'm going to do the except in the same line as the most outer try clause. Print you did not enter a valid index. And then we'll run the friends function. It looks like I made a slight error here. Oh, I forgot to put the equal sign. Except, let's just check this here. Oh, my bad. It should be in line with the inner try clause. There we go. Okay. So let's say I put in 2.0 or 2.3432. This should be just 2, which should give us dog as the friend that we've chosen. There we go. We have dog as the output, and we have the for loop of the tuple, so bird all the way down to pig, and the end loop. And let's try again. Let's say we do something random like that. You did not enter a valid index. And if I were to do 100, you did not choose a friend. Okay, great. So that concludes my lecture on try accept, and finally. I hope it's been insightful, and if you have any questions, feel free to ask. Thanks.